So yesterday we finished up with this slide, and I want to pay particular close attention to the little chart here on the right hand side where it has sine and cosine with the angles of 30, 45, and 60 degrees. So notice all those numbers. I'm going to show you how those relate to the unit circle, which is going to come up next. Okay, so let's explain the unit circle. The unit circle is a circle on the coordinate plane, and it's a unit circle because all the radii around it are a unit of 1. Okay, so in all the directions they're an absolute value of 1. So you got 1 to the right, 1 up, 1 to the left, 1 down. Ones on the left and the down are going to be negative because on the coordinate plane, those are negative. Okay, so what we're going to see is these little triangles that we can make inside our unit circle. Okay, so let's just put a random point there. Okay, if we go to the right on a unit circle, that's the x value. If we go up, that's going to be your y value. So that's going to be, that point is going to be x comma y. Okay. Now, to finish off the triangle, we put our hypotenuse there. And our reference angle is always going to be by the origin of the coordinate plane. And this hypotenuse is a radius because it goes from the center of the circle to the outside edge. And if the unit circle has a radius of 1 all the way around, that radius is going to be 1. So that's what our triangle looks like. And let's explain what it means. Okay, so if you did the sine of theta, it would be the opposite over the hypotenuse. Well, the opposite is y, and the hypotenuse is 1. So the sine would just be y over 1, which would just be y. Okay, so if you're looking at the sine of an angle on the unit circle, and it has a point on it, the y value of the point is going to be the sine function. Okay, for cosine, cosine is going to be the adjacent over the hypotenuse. So the adjacent is going to be x, hypotenuse is 1. So the cosine is going to be x, because x over 1 is just x. So any point on the unit circle that has an x value, that x value is going to be related to the cosine. Okay, so now let's look at our unit circle. We've done all these degrees around the unit circle. You can see you have 0 degrees, 30 degrees, 45, 60, 90, all the way around to get to the end of the circle. Once around the circle is 360 degrees. Now we've already done conversions between radians and degrees to radians. That was the first lesson of this unit. Okay, so if we did those, we're going to see something. Now, the other thing we're going to see is these points. Now, I kind of want you to remember back to that chart we started with, and we're going to show you some things with this. Okay, so we've already seen that on a unit circle, it has a point on the axes of 1 and 0. So at 0 is going to be 1 comma 0. All right, if we converted 30 degrees to radians, it would be pi over 6. All right, and now if you remember your chart, for the cosine of 30 degrees, we would have root 3 over 2. And for the sine of 30 degrees, we'd have 1/2. And that's where they come in. So if that's our point at 30 degrees, all right, the point's going to be root 3 over 2 and 1/2. And the root 3 over 2 is going to be related to cosine. The 1/2 is going to be related to sine. All right, if we think back to the chart and our conversions of 45 degrees, that would be pi over 4. And 45 degrees for both sine and cosine is going to be root 2 over 2 and root 2 over 2. Remember, x being cosine and y being the sine value. All right, for 60 degrees, if we converted that degrees to radians, we get pi over 3. And then we would take the cosine of 60 degrees is going to be 1/2. And the sine of 60 degrees is going to be root 3 over 2, which is the same value as we saw on the chart from yesterday and the beginning of today. Okay, we kept going around the unit circle, and you converted all the degrees to radians, and then changed or used all those same values as we went around. This is what happened. You'd have 90 degrees would be pi over 2, you get 0 comma 1. Now, on the rest of the unit circle, the values are going to be related. It's just they're going to change signs depending on where they are on the coordinate plane. So on the left, in the quadrant 2, up on the left-hand top corner, all the x values will become negative. The y values will stay positive. If we go to quadrant 3 in the bottom left, both the x and the y values of your point will become negative. If you go to quadrant 4 on the bottom right, the x values will become positive, but the y values will be negative, right? And they're going to be related to the 30, 45, and 60 degree points that we already have in the top right quadrant. Okay, you can see on this slide that they're color coordinated. So as we go around, the points will be related to the same colors. They'll just change signs based on where they are in the unit circle. Okay, and as we get to 2 pi. All right, now one thing about the unit circle is 0 radians and 2 pi radians are in the same spot. Okay, so if you have 0 radians or you have 2 pi radians, they are still going to have they're both going to have the point of 1, 0. Okay, so this is what the unit circle looks like. We'll give you a copy of this, but in the note sheet today, there is a unit circle that you're going to use. So fill it out, use this slide, and then you're going to find the various points of different radians or degrees. And good luck with that. And what we're going to do tomorrow is we're going to show you how the unit circle is used to graph sine and cosine functions. All right, and we'll see you tomorrow.